So our group decided to do example 4.c.8. The givens are given in the top left of the board. We are finding theta max and the energy loss due to the impact. And as you can see in the schematic in the bottom left, a bullet is hitting mass A, which is hanging from a cable, and it is getting hit up to a maximum, which we're finding that theta value. So we started off by drawing three body diagrams of three different phases. One is just the bullet coming in. One is when it hits the block with the bullet in it at the very bottom, and then two is the maximum with the bullet in it at your theta. And the coordinate systems are I hat and J hat, which are the same as N and T. So Hayden is working on the impact equation right now. The velocity of the A initially is 0, so that cancels out at state 1. The velocity of the A and the N mass are going to be the same because this is an inelastic collision. So Hayden is going to solve for V2, Vn2 right now, which will be used in the next step to solve for theta. So now we have an approximate value for Vn2 and the symbolic equation. So now Hayden will start by finding the kinetic energy for the mass at state 1 and state 2. And remember, this is not the initial, this is state 1, which is at the very bottom with the bullet in it, and state 2, which is the maximum with the bullet in it. So the weights are given, so we are divided by gravity, so we're going to be in pounds mass. And because it's a maximum, T2 is going to be 0, so it's going to be 0 velocity at state 2. So step 7, we're going to do potential energy, and for this it's just going to be weight. At state 1, it's just going to be straight down based off that L value and the total weight. And then for our state 2, it's going to be, you're going to have to do a little bit of trig using the theta value, and that's how you're going to find it. And step 8 are non-conservative, there are no non-conservative forces, no friction or anything. So those two will drop out, and we're just going to have T1 plus B1 equals B2. So as Hayden plugs these values in for the work energy equation, we're going to have two equations and two unknowns, so we'll be able to solve for theta here. So doing some algebra, you can set theta equal to the rest of the equation here, and you can solve, you can either plug Vn2 using that approximate value or just solve it and put symbols into that Vn2 as well. So that equation there will get you your theta max. And we got an approximate value of 21.8 degrees. Let me plug everything in. So now we're going to go to the energy loss due to impact. And to do this, we're going to do the change in kinetic energy. And this will be using the initial state and state 1. So the bullet's going to be coming in at initial kinetic energy, and then once it makes that impact, right after that, we're going to be able to find the kinetic energy at state 1, and this difference will be the loss. So So that is the equation we got for our change in kinetic energy. So then when we solve for this, we get approximately 10,043 foot-pounds force. Or, because thermal's done, we got 12.9 BTUs. And that's going to be your energy loss due to the impact.